Welcome back to our YouTube series on exploring polymer materials that we take for granted. In our last episode, we discussed gloves, so it's just latex and nitrile gloves, critical components of the approach to personal protective equipment in the healthcare and scientific laboratories. And today we're going to continue our series, making its way out of the laboratory, looking at another piece of personal protective equipment that is not just in the laboratory and healthcare settings, but it also is in everyday life. And that is masks.
We hope you enjoyed our earlier episode on gloves, and today we'll make a deep dive into the science behind masks.
So what we want to ask is, what are the places and situations where we anticipate wearing masks?
Masks are critical in situations where we're exposed to very fine particulates and are helpful in reducing the spread of viruses capable of aerosol transmission. Let's start with thinking about two examples. What do we mean by very fine particles?
So for very fine particles, what we're typically thinking about are particles with sizes near 1 micrometer in diameter. So these are really quite small.
That's really small indeed. How do masks physically block these particles? Well, there are 4 different real mechanisms, right? 3 of which are pretty similar. First, let's consider inertial impact, interception, and diffusion. These 3 mechanisms are all very similar and are essentially caused by the particle colliding with a fiber in the mask and becoming trapped. This works for both very fine particles as well as some larger particles.
The 4th mechanism is what's called electrostatic attraction. And this is where a charged particle interacts with the fiber in the mask that has an opposite charge of that for the particle. This action works for many different sizes of particles, not just small or not just large.
Now that we know how masks trap particles, let's look at different types of masks. Let's start with the much sought after N95 mask.
So I have an example of one of those here. So one of the questions to think about is what does it actually mean for a mask to be an N95 mask?
Yeah, that's a great question. So it gets a distinction between a mask and a respirator. What we refer to as an N95 mask is technically a N95 respirator. It must be capable of blocking 95% of the aerosols it faces. During the testing of respirators, tests are commonly use particles with a diameter of 0.1 microns. That, for scale, that's about 10,000 times smaller than a typical raindrop.
So blocking 95% of particles sounds fantastic, but why shouldn't we get a respirator that blocks 100% of particles?
Well, it kind of gets to, the practicality. Blocking every single particle of such a small size is really difficult. Plus, blocking more particles begins to limit how much air can be transmitted through the respirator. So there are some trade-offs here in terms of performance. But let's move to thinking about what these N95 masks are made of.
These N95 masks are typically made of many, many layers of thin polypropylene fibers. And much of the mask is made through a process called spun bonding, where very thin melted threads of the polypropylene are blown onto a surface in order to build up a layer of fibers that can be bonded together using heat. Multiple spun bonded layers, often at different densities of fibers depending on what you need, are created and then assembled and put together to form the masks. And you can typically take these layers and bond them together using heat or high pressure.
Other types of masks are also made with polypropylene, right?
Yes, many disposable surgical masks are also made of polypropylene, and I have one of those examples here. It's the common sort of white on one side and blue on the other side, sort of pleated surgical mask that you might see. Typically these masks have much thinner or less dense layers, and sometimes these spun bonded polypropylene layers are actually used to cover both sides of a textile support material, just to give the material a little more rigidity for day-to-day use.
Right. And surgical masks are different from N95 masks in that the polypropylene weave is not as tight. This allows for more airflow, and these masks are a little bit simpler to manufacture as well. While the surgical mask does not stop nearly as many particles, They are quite good at stopping larger particles that may be inhaled. In this sense, surgical masks are really intended more to protect those around the wearer, while in comparison, an N95 mask is intended to protect both the mask wearer as well as those around them.
Right, so that purpose of protection, protecting yourself from others, and then also protecting others, you from others, is interesting, particularly given that both many of these surgical masks and also the N95 masks really have a common thread in that they're both typically made of polypropylene. So let's dive a bit deeper into this polymer material and think about what actually makes polypropylene such a good material for these two very different types of masks.
Cost is a significant component, and polypropylene is generally pretty economical to manufacture. It's also, as well as economical, the process to synthesize or make polypropylene is very efficient. It has good durability and stability. It also has a relatively low melting temperature, or very accessible, of about 320 degrees Fahrenheit, which is about 160 degrees Celsius. And that really allows thermal heating to be used to adhere the layers of the components together. This combination of factors makes polypropylene a really good choice for a number of applications.
Right, that's really interesting. So there's a number of solid benefits to using polypropylene, but what about its drawbacks?
Again, the low melting temperature is a bit of a downside. It means you can damage it if it gets heated too much, for instance, by ironing. Polypropylene can also be a bit difficult to dye, which is mainly due to its hydrophobic or water-fearing nature. Dyeing polypropylene sometimes requires introduction of polar groups during the manufacturing process.
All right, so here we've mentioned the hydrophobicity of polypropylene, but one of the things that our viewers really might be interested in is where does that come from? So what is the structure of polypropylene?
Yeah, that's a great question. So polypropylene is really comprised of, it's a hydrocarbon-based polymer, and it's really based on these repeat units of propylene monomer, which is two carbons in a row with this side methyl group. One of the key things about polypropylene in these applications is that the relative configuration of this methyl group on all the different units along this polymer needs to be oriented the same way. They can be sort of pointing out at the viewer, like represented here by this wedge, or pointing back, like represented by these dashed lines. But in both cases, the relative orientation is the same. And that really enables the polypropylene units to really have the structure, that we're looking for.
Yeah, it's a really interesting structure, particularly those differing possible orientations for those methyl groups. So what does the structure of the polypropylene polymer mean for the resulting structure of fibers that are made? I mean, there's actually some crystalline content to these, right?
Yeah, that's absolutely true. So there's a balance between, so the mix of composition between crystalline components. So these are materials that are close packed together in some sort of, ordered three-dimensional structure, and some amorphous regions which are not structured. And the crystalline regions really provide a lot of the strength and rigidity to the material. But it's also one of the reasons why it can be quite hard to dye polypropylene while it's manufactured.
That's really interesting. And so we've talked now about good synthetic options for masks, right? This polypropylene that can be used in a number of different ways to produce surgical masks or N95 masks. But there's other options for masks. So I'm sure our viewers have heard of many people making their own masks at home. Perhaps many of our viewers have made their own masks at home. And I'm guessing that not everyone has the equipment to make spun bonded masks at home.
Yeah, that's correct. Our viewers can buy or make their own masks at home from a wide range of fabrics, including natural fabrics such as cottons, synthetic blends, or fully synthetic fabrics.
So maybe let's take a quick look at cotton. I mean, this certainly classifies as an often overlooked polymer. And cotton is a polymer, a common polymer that's actually used for masks. So I have an example of a cotton mask here. Dominic, you have one as well. So cotton is made of cellulose, and it's a naturally occurring polymer of glucose. Although cellulose is not often thought by the general public as a polymer when we talk about polymers, It's a biologically made polymer. And a chemically modified version of cellulose was actually what led to one of the first successful synthetic fibers, rayon.
So what exactly is a cellulose polymer? What is it made of?
So cellulose is a polymer of the sugar glucose, and within cellulose, the sugar molecules or the sugar monomers are linked together in a very specific way, creating a repeating unit. So you'll see there in the center of the structure that Dominic has displayed, you'll see the glucose monomer, and you see that those are linked through bonds both on the left side and the right side of that molecule, which are called glycosidic bonds. So this runs throughout and really creates these very, very long polymers, which can then further assemble into things like fibers. So, in taking a look at glucose and building up into this cellulose polymer, thinking about different materials that could be used, the ability to filter out small particles really depends a lot on the type of fabric that's used, right? So typically fabrics with a much tighter weave are going to be better at filtering out small particles. And the result there really is that cotton fabrics vary between being able to filter out somewhere between 10 to 80% of the very fine particles, right? This is different when you compare cotton masks to something like the N95 masks that we talked about. And so, if you think about how these actually work, in addition to the mechanisms that we talked about for the polypropylene masks, the cotton mask can also filter particles using that electrostatic mechanism, where charged fibers within the mask are actually capable of attracting particles of opposite charge. For larger particles, though, the cotton fabric masks perform just as well as the N95s.
And these materials and the masks are made from natural or synthetic textiles work using the same mechanism we mentioned earlier. Inertial impact, interception, diffusion, and in some cases when we have charges, electrostatic attraction.
Right. So a big part of the consideration here is really how or why you'll be using the mask. So if you were exposed to a very large amount of very fine particles or maybe respiratory droplets from an infected person, a well-fitted N95 mask is a great choice. And this is typically a situation you'll encounter if you're a frontline medical provider.
In contrast, if you're looking to protect those around you, or if groups of people want to protect others in their group, providing everyone with natural fabric or synthetic material surgical masks is a great choice. There are benefits and disadvantages to each type of mask, but regardless of the type of mask you'll be wearing, using a mask provides you with protection against particulates that you just wouldn't get without wearing a mask.
So the next time you're about to head out and you grab your mask, maybe take a second and think about the science behind these masks and the properties that make them work.
Okay, so that kind of wraps up our video on masks. We hope you've enjoyed this video and that you learned something new about polymers, their applications, and the underlying chemical properties that have an impact on how masks are made. In our next video, we'll continue our exploration of polymers in personal protective equipment and focus on eye protection. See you next time.